Thank you, Dan. Thank you. Good morning. The technology I'm about to share with you is set to revolutionize the way that we generate and use energy on this planet. It has the capacity to do things that no other form of energy generation can do, and I'm very proud to say that after several years of hard work, my team and I are about to make it a reality. Space-based solar power, a term we're going to be hearing a lot more of as we close out this decade, and by the end of this talk, I'm sure you'll understand why. The solar industry today is a $40 billion a year market producing 20 gigawatts of power. Unfortunately, that's less than 1/10 of 1% of the energy we currently demand. Without variance, it's usually generated the same way. We put solar panels either on the ground or on rooftops where every night it gets dark. They wait for the sun to rise and then harness whatever energy they can before the sun sets. Not only do we have the day-night cycle, which guarantees intermittency, but what about clouds and weather and different variants on gradients of latitude? But what if there was a way you could actually harness the power of the sun 24 hours a day and be able to capture that and use it in a way that provided the holy grail of renewable energy, baseload solar power? Well, we can do that. By taking solar panels and putting them into a geosynchronous orbit, we have the technology to be able to convert that electricity into a transferable radio frequency, send it back down to Earth with pinpoint accuracy, safely and reliably, to create constant energy generated by the sun 24 hours a day. Now, that question has always been asked of space-based solar power. Can it really be done? And if so, how? The questions now really have been centering on, when will it be done? And who's going to be first? I'd like to answer that by saying space energy and now. But before I get into some of the details, I'd like to share with you some of the history. Like every great idea that has the power to change the world, space-based solar power was thought of way ahead of its time, when back in 1968, a renowned scientist, Peter Glaser, first proposed the concept. In the 70s, NASA did some studies and tests to verify that the physics of wireless power transmission worked and that we understood the technology. More studies done in the 80s and then a fresh look in the 90s all drew the same conclusion, that yes, space-based solar power is technically feasible. We know how to do this. The challenge has never been technology. The challenge has always been economics. Being able to make the business case close is what's prevented this from happening today. And the first company to be able to do that wouldn't just start a business, but it would launch an industry. Let's fast forward, 2006, something happened. A paper came out written by Lieutenant Colonel Michael Hornacek of the US Air Force called War Without Oil. And what it did, it centered on the impending challenges we face as we enter an era of depleting hydrocarbons known as peak oil. It also projected a scenario out 15 years or so from today where the world could get very easily drawn into an all-out global conflict over the last remaining scraps of non-renewable energy. That scenario was taken quite seriously by the National Security Space Office of the Pentagon, whose job is to actually mitigate war prevention and look for different solutions that can actually take us on peaceful paths. They decided to look around at what technology or what directions we could take that would avoid this potential scenario, and everywhere they looked, the same thing that kept coming up to the front: space-based solar power. So they went over to NASA and they said, hey, is space-based solar power real, and are we doing it? And NASA turned back to the Pentagon and said, well, yes, it is real, it can be done, but that's energy, and we do space, not energy. So the Pentagon then went to the Department of Energy and said, well, yeah, space-based solar power, we understand it's real, are we doing it? And the Department of Energy turned around to the Pentagon and said, space what? Yeah, we do energy, not space. So in order to find out and ask the question, is it real, and does the promise it hold, is it viable? The Pentagon decided to do their own study, and they enrolled 170 of the world's top experts. And they produced that study, and it was released on October the 10th, 2007. And the conclusions are very clear. Yes, space-based solar power is possible. Yes, the promise it holds is enormous, and the time to start doing it is now. So the credibility that gave space-based solar power was enormous, but not only that, it actually earned the 4 co-authors of that study what's been called the equivalent of the Nobel Prize for Space, the prestigious Space Pioneer Act Award. And this is them receiving it. Well, why all the fuss? Why all the urgency now? Well, I'd like to address that in 2 ways. One is to actually look at the energy crisis that we're currently facing. A lot of people understand that, we live in an energy-hungry and resource-poor world, or at least we're being accused of being poor on how we use the resources that we have. But I don't think we understand the magnitude of the enormity of the challenge we're facing. One man that does is this man, Mike Sneed, who, apart from being an expert in spacefaring logistics, is also a very proficient energy modeler. And last year, he wrote a very comprehensive report that asked the question, if we're to get off our addiction to hydrocarbon energy, then what would we need to replace that with, and what's the likeliest build-out scenario that we could actually match that up to? And he did that for the United States and the world in general. I'd like to share with you his scenario for the US, because it was quite, as I think you'll see, quite astounding, some of the stats. He proposed that if we just take the US, if the US was to build 70 new 1 gigawatt nuclear plants, if it was to build and install 1 million large wind turbines across 5,000 miles of coastline, if it was to add the equivalent of 15 extra Hoover dams to max out its hydro, if it was to upscale its geothermal capability by a factor of 50, if it was to collect all of the 2 billion tons of non-food biomass and use that per year, and in addition to all of that, if it was to build a staggering 60,000 square miles of ground-based solar, under that scenario, cumulatively, by 2100, not only would we not be able to provide even a third of the energy that we're likely to use, but if that happened today, we couldn't replace the fossil fuel usage in the US. Well, that's the energy scenario. And I don't just want to talk about energy, because what I'd like to talk about is the fact, yes, we need space-based solar power. We need it as a complement to every existing form of energy that we need to generate, invest in, and look forward to bringing online right now. It's not just the answer. But I want to talk about something that's far more important than energy. I'd like to talk about something, what I call the real promise of space-based solar power. Because let's just check in for a minute. We're talking about a technology that has the ability to transfer energy on demand anywhere on Earth in real time as it's needed, 24 hours a day. Nothing else can do that. The implications when we start assessing that are outstanding. They're absolutely astounding. If you take it from a humanitarian or an environmental perspective, I mean, the world governments, NGOs, the UN all understand that one of the fastest ways to take people out of poverty in the developing world is to give them access to electricity. That's why the World Bank has made it one of their mandates to make renewable rural electrification one of their, let's say, their high priorities. The challenge is that most of these areas that be affected the most can't get onto the grid. Space-based solar power could actually enable rural electrification like no other form of technology. And if we just focus on food and water for a second, I'll show you the implications of that. Well, one of our team recently met with one of the federal ministers in India that was in charge of food production, and he wanted to see us because he understood the implications of space-based solar power and what it could mean for rural electrification. But he shared with us some interesting information. He said that the reason that they have so much hunger in India is not down to food production. In fact, they produce all of the food in India they need to feed everybody in India. He said the biggest challenge and the reason they have so much hunger is that 1/3 of all the crops grown in India spoil from harvest to market because of lack of refrigeration. And if we were able to bring a technology that could put remote locations with energy so we could generate refrigeration, you could have a massive impact on India's hunger almost overnight. If we take water, water is also a huge issue, not only in the third world, where the World Health Organization is very clear on the fact that lack of access to clean water is one of the biggest challenges and one of the largest causes of death, disease, and suffering in the third world. Things like cholera, typhoid, and specifically diarrhea are prevalent in areas that don't have access to clean water. Well, we can tackle this today with existing technology, something called atmospheric water generators. They take water out of the air and actually provide purified, they take the air and make purified water. This is the village of Jalamundi in India, which this year became the first village in the world to have all of its water powered by the air. Now, we can put these units all over the third world and create massive, massive reductions in poverty and increases in quality of life. The biggest challenge as to why that doesn't happen is because those areas don't have access to power to make these machines work. Space-based solar power could have a huge impact on something like that. Most people understand that water